Is it working? 6 minutes into the stream. Has it started now? I think I should refresh the page. Okay, I'm live from 21 seconds. Okay. Ah, So, if I remember, today's goal must be yes, we have to build the ADC. I have written also in description of the video. We have to build the ADC and with rsync support, create VMNets as create VMNets and add them as per need to whatever servers, then enable bonding between same network VMNets. Configure WinAdmin VM to actually work with Windows accounts in Samba. Then make Linux and Windows workstations. I think now, this point, make Linux and Windows workstations. This is optional. I mean, why? If this works, no, sorry. If this works, find a way to pool VMs. Then I don't need this. And I will find a way to configure some templates kind of thing and automate all of them via Ansible. Okay, so these two will go hand in hand, and I'll totally eliminate it. Then I have to finally study WSO to login and dashboard portal to integrate it with this work. Okay, so we are up, guys. We did a lot of work to configure domain controller, and this is the work. So I should export this PDF, freelance 8 notes. Fine. This is exported itself in dark mode. Oh no, no, no. I have transformed my reader to dark mode. Let me just open my chat side by side. Fine. So let's work through it. We have our Gemini. Configure ADC, additional domain controller with rsync support. Today my keyboard actually many of the keys started not working. Many of the keys were not working, and I thought, what might be the problem? Actually, I switched the input. That is a Wi-Fi wireless dongle for wireless connection of keyboards. This is my keyboard. It's Portronics wireless keyboard, mechanical, and somehow when I switched my input from this 2.4 gigahertz wireless adapter to Bluetooth mode, everything started working. All the keys started function normally. But then again, problem occurred, and I don't know how. I just kept on working, kept on pressing, and it started working. And I'm quite worried because my mouse is also misbehaving on left click and keyboard also. So it's quite scaring me because I don't have any money right now to buy if they die. So please don't die. Hope that my keyboard and mouse never die. Okay. Help set up next task in the line, that is configure ADC. Additional domain controller with rsync support. Give very precise, think deeply, and give me precise steps. Let's wait. By the way, we can meanwhile start all these servers. Power on this virtual machine, power on the mirror, power on domain controller. Actually, I should have started them one by one because mm, they might mess up. It might not find DCP. Uh, e- e- I think I've messed up. Maybe let's see. Let's see. They should sync, right? I'll see. Start fast. OpenSense definitely takes a lot of time to start. Okay, that started. This is still starting. Okay, this waited on network and then it worked just fine. And it is also waiting on network, I think. And as soon as mirror works, it will work. Okay, SSH into 40. Yes, it works. SSH into 41. This is my mirror server. No, this is DC1. Mirror server is this. Okay, mirror and DC1. OpenSense is not configured on SSH. And by the way, OpenSense has what? Which OpenSense is IP address of 33 right here. Okay, I am mode. Okay, root. Here are the precise steps to build and configure additional domain controller ADC1 with rsync support, picking up exactly where your freelance 8 nodes PDF document left off. The document outlines your requirement to build ADC1 alongside DC1 using my client's domain and explicitly mandates rsync support for replication. Since Samba AD does not natively replicate the sysvol directory, which holds group policy objects, rsync combined with ACL and ATTR, access control list, and ATTR means, I guess, attribute package. You previously mirrored the standard solution. So now I have to provision my VM and open sense reservation for ADC1. In my notes, I can make ADC1, create a new Linux server VM for ADC1, assign network adapter 1 to VMnet 3, that is internal network. Then start the VM and note its MAC address during boot. Log into Open Sense dashboard at K. Go to services ERDHCP v4 reservations to add ADC1, and here we go. This is subnet is 10.10.10.32/27. IP address is 42. Following your schema where mirror 1 is 40 and DC1 is 41. Yes, and host name is ADC1 DNS servers 10.10.10.33. Domain name is this. Then I basically complete the base installation of the OS for a of the OS for ADC1, then prepare the environment as follows. By the way, that is already done, but still I'm writing this command. Sudo hostnames set hostname ADC1, hostname control set hostname ADC1. Then I will just point my apt sources to the mirror1 server exactly as I did for DC1. Point the apt sources to the mirror1 server exactly as I did for DC1. Bash. This is one command and this is second command. Separate them by a line. Then you have to update apt and install sudo apt update sudo apt install samba smb client krb5 user winbind rsync samba ad provision samba dsdb modules samba vfs modules acl attr open ssh server. Let me check spellings. Samba correct, SMB client correct, KRB5 user correct, Winbind rsync, Samba ID provision, Samba DSTB modules, Samba VFS modules, ACL ATTR Open SSH server. Fine. Note if prompted by Kerberos during installation, enter syedfazai.com DC1 and DC1. Then joining the domain as an ADC. Before joining, ADC must be able to resolve the domain for domain via DC1. Before joining, ADC1 must be able to resolve the domain via DC1. Temporarily hardcode local resolver to point to DC1. Remove the default Samba configuration, join the domain controller using the administrative. Okay, so we have to temporarily hardcode the local resolver. We unlink the file and edited the file ourselves and provided it the DC1's IP address. Then we remove the default Samba configuration file and use our own command to make the file again. Copy the Kerberos config and configure services. All right. Repoint DNS of ADC1 to itself. In resolve.config itself. Verify the replication status. Configure rsync accessible replication. Because Samba does not natively handle file replication service, group policies won't sync automatically. We must use rsync. On DC1, generate an SSH key for the root user to allow passwordless syncing. But we already have an SSH key in place here, I guess. ADC1 authorize the key. Paste the public key from DC1 here. Then make that file executable. 4 plus 2. 4 is 4 is read, I guess, and 4 is execute. 2 is write and 1 is read. Yeah, or I'm totally saying in reverse. On DC1, verify the connection and do the initial sync. Extended attributes and ACLs flags are strictly required. You have to maintain Windows file permissions utilizing the ACL and ATTR packages you previously mirrored. On DC1, automate this by setting up a cron job and add the following line to sync every 5 minutes. See, I install the packages and now I have to join the domain. But I temporarily hard-coded the local resolver, right? Let's first do this and then I'll say about configuring it permanently. Temp hardcode the local resolver to point to DC1. Remove the default Samba configuration file. assembly.conf. Join the domain controller. Using administrative password. Okay. Copy the Kerberos config and configure services. Sudo copy from where lib samba private krb5.conf etc krb5.conf system control stop smbd nmbd winbind system d resolved sudo system ctl disable smbd nmbd winbind and system d resolved. Then sudo systemctl unmask samba addc systemd resolved. Enable now samba addc resolved. Repoint the DNS of ADC1 itself. Itself now that it is a DC. So I think you temporarily did that, and I think you have permanently done as well, right? Verify the replication status. Sudo Samba tool drs show repl. Because Samba does not natively handle file replication service, group policies won't sync automatically, so we must use rsync. If I already have the key, then I'll just copy that key on a DC1. I'll paste that key from DC1 here and do chmod. Okay. Let me first complete till this process and then I'll move to this final phase of doing rsync. Okay. So here we have to create a new virtual machine. This is going to be Ubuntu Live Server, yes. ADC1. I'm going to provide it only 10 GBs and store that virtual disk as a single file. Let's customize this hardware. Just provided 1 GB of RAM, single processor. Uh, Network adapter changed to VMNet 3. Start the VM and note its MAC address during boot. Finish. So this is right. Custom VMNet 3. Auto detect. Fine. Power on this virtual machine. Let me just zoom it. Try and install Ubuntu server. You won't be able to connect because there is no internet connection in VMNet 3. So just give up, bro. Don't wait for cloud in it. You will fail miserably. How much time before that fails? Okay, it finally failed. Yes. English, English, yes. Ubuntu server. Okay, wait. Can I go back? Yes. Go to help, enter the shell, show me IP ADDR, show me INET value, oh no, no, no. Ether 29, that part will be same. E9 F9 A1. Okay, we have E9 A9 F1 MAC address. I'll just write it here for easy access. What is it? 000C 29 E9 F9 A1 002 E9 F9 A1. Fine. Let's go here. Freelance. So go to services, Kia DHCP4, reservations, new reservation. Network is fine. IP address is going to be 42. MAC address is going to be 000C29 E9F9 A1. E9F9 A1. Host name is going to be ADC1. Description is going to be additional domain controller. Nothing in routers, nothing in static routes, nothing is classless static routes. DNS server is going to be 10.10.10.33, and then domain name is going to be Syed as, wait, this one, yes, and it's done. Save, apply. I have applied. Now I have to complete the base installation of VMware. So I will just reboot, I think, if it works. Yes, not in mount, na. Yeah, I haven't even installed. How can you unmount? Client MAC address 000C29E9F9A1. In GUI did this. You are trying to find the DHCP. You're trying to find something. Well, I think I shouldn't have rebooted, but just hmm. Wait. Exiting from Intel PXE ROM. Operating system not found. Of course, you won't find it. Shut down guest. Power on this virtual machine. Try and install Ubuntu server. This will take some time. 42. Yes. I think I'm doing things quite fast now in comparison to previous streams. All of this setup require costed me like a lot of time, and I'm just speed running it. Once this is done, I will snapshot it. See, already I'm running 4 instances of virtual machines and how much RAM is being consumed. I'll show you my task manager. Something is messed up. Okay, fine. Um, 26% CPU, 61% memory is being used. Performance. Okay. I really hope to complete till WSO2 today. And please, please, please. After enabling async, I think I have to make bonds on all the servers. Maybe I can make the bonds later on, right? It's not very much compulsory right now. I just have to make similar VMNets, exact same VMNets, represent same network and fine. I have 2, 3, 4. I will make 5, 6, 7 and matlab 2 equals to 5, 3 equals to 6, 5 equals to 4 equals to 7. These clubbed VMNets will be bonded together via the concept of nick teaming, NIC teaming, that is nick teaming. I can do that thing at the end. So after this, I'll check this and configure my Windows admin VM to actually work with Windows accounts in Samba. But again, before that, I think I should make workstations, and I can research on, means I can directly jump to this step actually Abhi, after rsync was successful. Then just test if my workstations are able to join from this pool, right? And if any workstation is able to join the network, that simply means I can proceed to that means I can proceed to making I can proceed to make these group policies and stuffs. Okay. And for that I need Windows admin virtual machine. Fine. Workstation policies via Ansible. And after making after making workstations, after making Windows admin VM, then to um, apply those policies on Linux workstations as well, then I will need Ansible. And we complete all of this stuff eventually. And then I can study WSO2, apply it, make the Nginx servers, configure all the monitoring um, and logging of the servers. After doing this now, I will actually notify my client that I have completed my project. And this monitoring and logging, just mention separate. The new established servers need by monitoring and logging. So give me some days more. At least he will get a peace of mind that his work is done. Okay, by the way, this is done. Reboot. Fine. ADC1 is installed. Congratulations. So shut it down. Down fast, man. I don't even need Snapdeal. Just shut it. Yes. Edit virtual machine settings. Connect that power on. Uncheck. Now power on this virtual machine, and after powering on, I will just do the base snapshot. Yeah, this works. Base. How do I name base install? Base upgrade, you are here. Doesn't look right. Base. Okay, I have done the snapshot of base. Now I can only set up this SSH, Um, I have just slept for 4 hours. How much time into stream right now? 47 minutes into the stream. Oh yeah, sorry. etc slash sources dot list dot d slash ubuntu dot sources and dot backup sudo bash c cat etc apt sources dot list dot d local mirror sources local dash mirror dot sources types deb files uris from 10.10.40 noble repository studios. sudo apt install open ssh server systemctl status ssh is not active. Sudo systemctl start ssh. Now it is running. Okay, I'm into ADC1. Password authentication. Restart SSH. Install all these things. Kerberos 5. Sudo unlink resolve.conf. Ubuntu systemd resolved service is currently hogging port 53. Because of this, cannot bind port 53 to serve DNS request. Your notes explicitly included modifying resolve.conf to prevent this exit issue. I missed having you replicate that step for ETC1. Configuration file. So basically, after this episode and all of that, restart services before restarting things, right? So we do all the restart things and stuff right here. So maybe I should do all of these things right here. Sudo nano etc systemd resolve.conf. Restart this is systemd resolved and restart Samba UDDC. Resolve DNS is 127.0.0.1. Domains DNS is this domains ai.com DNS stub listener DNS stub listener is set to no, and that's it. Write out exit restart sudo systemctl restart systemd resolved restart Samba ADDC Samba tool DRS show REPL. If this is successful, then I'll just wait. If this is successful, then I'll just take a little break, 5 to 10 minutes, I guess, and then I'll continue with rsync and other things. Not quite yet. Hold off on the rsync configuration for just a moment. You are saying file not found. This is actually very common after seeing new domain controller restarting services. What's happening in Samba's knowledge consistency checker? The background process responsible for building the replication connections hasn't fully caught up with the topology changes yet. To ensure AD replication is completely held before layering async on top of it, trigger the knowledge consistency checker. It is successful. Force KCC to immediately recalculate the replication topology rather than waiting 15-minute polling interval. Kickstart the replication process manually for your main domain partition. This forces ADC to pull from DC1. Successful. If it asks for password, give it a verify health status again, and then check the replication status again. You want to see inbound neighbors display last success current time with 0 consecutive failures for all partitions. Outbound neighbors, what was previous? WR file not found. Where is this written? Okay, here. Here everything is successful. Okay, if you see file not found, just do Samba tool DRS KCC, then force the replication and check again. Fine. So give me a little break, guys. Just come in a few minutes. Welcome back, guys. So now we have to configure rsync. That is a fin. Okay. Ubuntu's default SSH configuration ships with a specific setting for root. This setting specifically blocks password-based logins for root, but it explicitly allows key-based authentication. Because the steps I provided have you drop in the root shell, generate an SSH key pair as root, and then manually paste the key, we are entirely bypassing the need for a password. The rsync command will authenticate that cryptographic key pair instead. This is actually the industry standard way to handle rsync for SysFall application because only the root user has registered authority to read and write the strict windows and TSALs without stripping them. You are completely clear to proceed with rsync steps. Okay, so first of all, I'll actually check on my DC one if I already have this. If I already have this key pair, let me just navigate to ls a ssh authorized keys. I don't have ID. Okay. Sudo su minus I'm on root ssh keygen copy paste bro. It has generated a pair and I will now copy this output. This is root at DC1 and I will paste sudo su minus dot ssh if it is not already created. It's just a minute. Fine. Authorized keys I will paste this key. But I'm confused for one thing. Unless I only have authorized keys, and in authorized keys file, the actual value of the key is this. How does it even work? I mean, if I do this, how am I able to log in? Hmm. This part is on DC1. Okay, make a file, building file list done, practical test.bat, Samba sysvol, sent, received. Check on ADC1. See, practical test.bat. On DC1, you can automate this process. No cron tab for root. I'm at the cron tab step. Do we have to run this command as root? And what to proceed with here? Select one. Did I read? Select an editor. Boy, at last you have to put this thing right here. Verify by using cron tab L. Fine. So this is done. We pasted the SSH key from DC1 to ADC1. We pasted the SSH key from DC1 to ADC1, where I saw ADC1 authorized keys actually don't have my hosts. That is public key from GitHub. Still, the SSH from host is working. So, what is this magic? If it the host machine connection from the wish authorized keys, the rsync connection. The very first command I had you run was sudo su minus. This is from root and this is from Devesh. And in Devesh, there are two keys. Sorry. Technical from a GitHub account currently has two different public SSH keys registered in its settings. People usually have multiple keys if they have set up SSH access on multiple devices, or if they had generated a new key but haven't deleted the old one. Now, because both keys were returned by that URL, both were saved in your dialectalframe.pub file, and subsequently both were injected into your authorized keys file at the same time. It is completely normal and actually a very convenient way to instantly grant all your trusted physical devices access to your new servers at once. Fine. So this is done. I should take on my another task. So let me re-export this PDF. Do I need to put anything else? I guess not. I guess not. Export to PDF. A4. Okay. Save. Fine. Now this is a new prompt to LLM. After workstations, more sense. The thought process is spot on. Leaving the VMNet bonding for very end is exactly what you should do. Build bonding and introduce network complexities and potential lockouts. If you want your core infrastructure entirely stable before messing with the network layers, setting up VM pooling strategy before configuring the WinAdmin VM and rest of the workstations is also the smartest path forward. In the context of VMware, VM pooling translates to golden image base VM and utilizing linked clones. This strategy is going to be incredibly efficient for a setup, especially since linked clones will share virtual disks with the base image, keeping the read times fast and preventing your 32 GB of host RAM and storage from getting chewed up by redundant OS files. Here is the exact workflow and practical steps. Construct the golden images. Instead of building the WinAdmin VM directly, you will build generic base VMs first. Create base VMs. Create one VM for Windows, WinBase, and one for Linux, that is Linux base. Base installation. Install the OS, install VMware tools, and run all the core system updates. For Linux, make sure your apt sources to your Mirror 1 server, just like you did for DC1, and install core utilities. Install any universal software you know. every machine will need. For example, browsers, curl, get standard forms, etc. Do not join them to domain yet. Generalization. If you simply clone a VM as is, every clone will have the same system identifier SID in Windows or the same machine ID in Linux. This will completely break your Samba ID and Kia DHCP server. You must generalize them. For Windows Golden Image, you need to run sysprep to strip the unique hardware and SID information. Open the administrator PowerShell prompt in Winbase VM, then execute some sysprep command. This VM will process the generalization and shut down automatically. Do not power it back on. Then for Golden Linux image, open the terminal, clean the package manager cache and machine identifiers. Okay, clear your bash history and shut down. Creating the pool. Now that your golden images are generalized and powered off, you will lock them in state. Take the master snapshot. In VMware, take a snapshot of the powered off WinBase and Linux based VMs. Name it something like sysprepped base. Spawn a clone. Right click the base VM, manage clone. Choose from existing snapshot and select your sysprepped base. Choose create a linked clone. This takes seconds to create and almost zero initial disk space. Name your new virtual machine, boot and configure. Power on the clone. Windows will go through a quick out of the box experience setup screen, assigning itself a fresh SID. Linux will generate a fresh machine ID on boot. Join it to fine. What operating systems are you planning to use for Windows and Linux golden images so we can ensure these generalization steps won't hit any of our specific snags? Actually, I was your mentioned way is nice, but I was thinking to maybe install a pure hypervisor Hyper-V inside VMware, and that can contain the pool because in our end term goal, given a user can log in, will log in on WSO2, I guess, then on a dashboard, they will see every web app or OS image they can spawn. So on browser, if some OS is going to spawn at instance, boot up, provide user login screen and etc. Yeah, Pash Guacamole. Uh, I need, I might need a proper API to Manual cloning inside VMware Workstation won't cut it. You need an you need an engine with robust REST API. Yes, it can absolutely be done, and running a nested hypervisor inside VMware Workstation for this prototype is standard practice for VDI, proof of concepts. How the dynamic spawning pipeline works: use a browser, okay, spawn workstation, call hypervisor REST API, nested hypervisor, clone and boot virtual machine, Guacamole API, stream RDP VNC session via WebSockets, use a browser screen, obtain IP hostname, recommended nested hypervisors with native APIs. And to make this work inside your current VMware setup, you can deploy one of the three nested solutions. First, ensure nested virtualization is enabled in VMware Workstation. Go to VM settings, processors. Wait, go to VM settings. Processors. Virtualize Intel VT. I think it is referring me to enable this checkbox in the uh, template operating systems, right? Option 1, Proxmox VE, best for full enterprise features. How it works: install Proxmox VE inside VM as a virtual machine inside VMware Workstation. Proxmox comes out of the box with a rich, well-documented REST API. You create a master VM template configured with cloud in it. Option 2 is Linux plus Incus KVM. Incus provides a native REST API designed specifically or dynamic container VM instantiation, spawning a lightweight system container or KVM VM takes literally 2 or 3 seconds. Perfect if your host hardware resources need to support multiple simultaneous test sessions without excessive overhead. Or Windows Server with Hyper-V. Create a Windows Server VM, enable Hyper-V role inside it, and expose a lightweight REST API wrapper like a custom fast API script or OpenStack WMI interface to run PowerShell commands like these. Right, fits directly maps to the Hyper-V block in your architectural drawing. Apache Guacamole hidden REST API. To avoid manually configuring Guacamole every time a VM spawns, leverage Guacamole's REST API. When a user requests a machine, your backend calls the hypervisor API to clone and boot the base image. Once the VM boots and registers its IP with OpenSense or KRDHCP, the hypervisor or DHCP script returns the VM's assigned IP. Your backend sends an HTTP post request to Guacamole's API endpoint with credentials, whatever. Guacamole returns a connection ID, and your frontend embeds the Guacamole client stream into dashboard inside a iframe or canvas view. Guacamole, okay. Which nested hypervisor stack would you prefer for this prototype? So we can use initial base image and API endpoints for it. Windows Server with Hyper-V. I think this is the least ideal solution for me. I won't go for Windows. Which one is an open source solution? Yes, you must check, but only on the hypervisor VM itself, the machine that will host the pool and not the individual base VMs. Checking this box allows checking this box, where was I? Allows the AMD V hardware instructions from your Ryzen 7 processor to pass completely through Windows 11 host and into the nested virtualization layer. Without it, your nested hypervisor will fail to boot any internal VMs. Question 2. Both are open source. However, for the specific lab environment, option 2 is best fit. Here is why. It outperforms the alternatives for your prototype. Resource efficiency. You are working with 32 GB, okay. Spin of OpenSense, mirror server, DC Nginx servers, memory will become a premium. Proxmox is incredible enterprise tool, but it brings heavy web GUI and cluster management overhead. Incus runs as highly efficient daemon on a standard Ubuntu Debian server, keeping overhead to nearly zero. And rapid command line testing. Since you want to manually test a chain before introducing Guacamole or WSO2, Incus is a developer stream. The CLI is incredibly intuitive. You can spawn a fully isolated instance in just 3 seconds with a command like wow. A native REST API. When you transition to automating the workflow, you can easily write Python or Bash scripts to hit the Incus REST API to clone, boot, or tear down instances dynamically. Option 3. You should tackle Apache Guacamole next. When building the complex pipeline, it's always best to build from backend toward the user interface. You build the Incus hypervisor first. You build Guacamole second. This allows to immediately test the core functionality by manually spawning Incus VMs via the CLI. This allows you to immediately test the core functionality by manually spawning an Incus VM via the CLI, point, pointing Guacamole to its IP and verifying the desktop stream works perfectly in your browser. The dashboard. You build the WSO2 last. Once the VM spawning and browser streaming are rock solid, WSO2 simply acts as an identity provider and uh, portal wrapping the working pieces together. Would you like the specific command line steps to get an Ubuntu server running with Incus so you can start testing the VM spawning process right away? So as we have decided on the architecture, please see the document I shared with you at start again and guide me in very precise details for configuring everything now. I think I messed up with the word everything. Nested hypervisor VM. Create a new server is recommended to match your mirror environment. Assign allocate 4 to 8 GB of RAM, 4 CPU cores, and 60 GB disk. Enable nested virtualization. Network setup is like this. For power on the VM immediately to jump, I must provide 8 GB of RAM to this. Nested hypervisor. New Linux VM. Ubuntu 24.04. Ubuntu server. Allocate 8 GB of RAM for CPU cores and a 60 GB disk. Enable nested virtualization from VM settings. processors. Check this virtualize VT, EPT or AMD RVI. Assign VMNet 3 as network adapter 1. Internal network. Power on and get its MAC immediately. Log into OpenSense at navigate to my timer buzzed off. I'm making another timer for 40 minutes. Service Kia DHCP v4 reservations. Forty-three host name hypervisor 1 DNS servers 33 domain name complete the OS installation on the VM and disconnect the ISO. Mirror setup and OS preparation. On mirror 1, mirror add incus, mirror add kmu kvm, verify the IP config by IPADDR should show 43, hostname controls set hostname to hypervisor 1, point the apt sources to your mirror server. It installed incus and kmu kvm. Add your user to incus admin group so you don't need sudo for every command. Sudo user mod add group incus admin user new group incus admin, initializing incus and bridging to the VMnet 3. Instead of just manually typing commands, I will create a Linux golden image, and then you can test spawning it dynamically via Python script simulating exactly what WSD will do later. Creating the golden image API interaction, the spawning script. Fine. Will acquire IP address of 50, 51, 52, like that. And all of the workstation will be spawned in this range of. Okay. I must also decide something for, you know, I think I need to make this network larger because maybe in final production ready software, we might need much more workstations. You should actually see from ADC and this. What were the steps for SSH configuration? The same as mm, after doing this much, you first have to install sudo apt install open SSH server, open SSH server, systemctl start SSH on host 8. Fine. Seventeen, 18, 21, 27, 28, 31, 36, 37, 39, 40, and same steps like these in here as well. Just that this much. So apt update 14, 15. Sudo apt install open SSH server SSH on host to this 43 on 43 on 43. Ah, I can continue. Incus admin. We need to configure Incus so that when it spawns a workstation, that workstation gets an IP from Kia DHCP pool in it. Answer the prompts as follows. Cluster, no. Storage pool, yes. Network, yes. Then ask to configure the network bridge. Tell it, tell it to use your existing interface, example ETH0 or ENS33, whichever interface is tied to VMNet 3. Configure network bridge. It is ENS33. This uses MAC VLAN, so spawned VMs share the VMNet 3 broadcast domain and receive IPs from OpenSense. Launch a base container. Execute a command inside it to clear the machine ID. Linux base. Stop Linux base. Snapshot create Linux base. API interaction. Unix socket by default. Here's a Python script so you can run Hyper-V. Let me complete these many steps first. Hyper-V hypervisor 1 new virtual machine. Hypervisor 1 assign it 60 GBs of space. Customize hardware provided at least 8 GB of RAM and number of processors should be 4 and you have to virtualize this. Also assign this is this. Okay, done. 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 MAC address step. I hope it starts. Virtualized AMD is not supported on this platform. Without checking it won't work. To fix this and allow nested virtualization, you have to strip away Windows hypervisor layer so VMware can interact directly with your CPU. Turn Windows features on or off. Uncheck the following items if they are checked. Uncheck Hyper-V. There is Hyper-V. Virtual machine platform. Windows hypervisor platform. It is already unchecked. And if you try to find Hyper-V, Hyper-V is just not visible, I think here. Windows Sandbox. Disable core isolation. And I need to restart my host computer, so I will need to end my stream. Okay. Windows uses hidden hypervisor for virtualization based on virtual security, which also blocks AMDV pass-through. Open the Windows Start menu, type Core Isolation under Memory Integrity, toggle the switch to off. Okay, after that, proceed directly with step 2. Core Isolation, Memory Integrity, toggle switch to off. Memory Integrity, toggle switch to off. Disable the hypervisor launch type. Open PowerShell as an administrator and run the following command. You can just do sudo. The operation completed successfully. Set hypervisor launch type off. After the reboot, the VMware workstation will have exclusive access to AMD extensions, and hypervisor 1 will boot successfully with the nested virtualization checkbox enabled. Disabling virtual machine platform and virtual Windows hypervisor will completely break WSL2 if you apply this fix. Your local development environment utilizing WSL2 in NeoVim and Wisdom will be disabled and unusable for as long as this lab configuration is active. If you need to keep WSL2 active. If sacrificing a local Linux environment is not an option, you can leave the Windows features turned on. Click no on that error prompt and uncheck the. We can still use hypervisor 1, but we will pivot from spawning full virtual machines to spawning system containers. No, I think I don't use WSL2 a lot. Okay, so I'm fine. I'm fine with not using WSL for some time because I don't really use it much anyway. I just have it in case is ever needed. Just tell me after completing this project, how can I recover WSL2 again or switch back and forth? However necessary to me. How to restore WSL2? That makes total sense, and the good news is that turning these features off does not delete or modify WSL Linux configuration files or whatever. Everything stays completely intact on your storage drive. Okay. When you finish a project, whenever you switch to back in files, okay. Re-enable Windows features, open a recheck virtual machine platform. Click OK, re-enable Windows hypervisor by using this command. I'll just write the steps in Notepad. That is updating. Sorry. Is it done? Yes. The steps are how to turn on WSL after freelance 8. Okay, guys, I think it's time for me to restart according to this, and thus I will continue fast switching between modes. Okay, now I can continue with my steps. So I will continue further my of my task in next stream. Part 4 coming soon. See ya, guys. Let's meet in next stream. Bye.